Hello everyone, welcome to my YouTube channel. I'm Kaushik here. So today we will learn about orthogonal matrix, which is a special kind of matrix using the inverse properties and the transpose properties. So orthogonal matrix, the main property is like let me just put the black color. So the main property is if the matrix is orthogonal, then the inverse of that matrix is equal to with the transpose of that matrix. So I think by the time you are kind of familiar with the inverse matrix and transpose matrix, if you are following my channel, so we covered these things like inverse matrix. When you are very simple, if the inverse of this is basically um, 2 by 3 will be 3 by 2 kind of thing, and inverse matrix is basically the rule is if the matrix has an inverse matrix, then the multiplication or product of matrix and inverse matrix will be a identity matrix. So now if you already cover my inverse matrix, so I clearly mentioned that inverse matrix, the rule is um, not all the matrix will have an inverse matrix, but a matrix and then inverse will be identical matrix. So that's mean let's write down that property. So inverse matrix property, you will be surprised like why I'm talking about inverse matrix. We are talking about orthogonal matrix, but why I'm talking about inverse matrix. Inverse matrix property is that if the it has an inverse matrix, then the product will be identity matrix. Now when we are talking about an orthogonal matrix, we know that the inverse is equal to the transpose. So we can write this way also, right? This one we can substitute by the transpose. So this is another also important property for when the matrix is orthogonal, we can say that the matrix and its transpose equal to identity matrix. Hope are you clear on this part? Okay, I'm just substituting this by this and I'm getting this property. Okay, so finally what we can write here, that if it is an orthogonal matrix, then the first thing is this is the first thing, and then because we know the identity matrix has a property that inverse of that matrix, so then we can write that matrix and its transpose equal to identity matrix. You can write provided inverse matrix equal to AT or A is orthogonal matrix. Clear up to this? I think now it should be very clear. Along with that, another property also just also true, which I'm not proving again, but the A transpose and A will be equal to identical matrix. Okay, if A is an orthogonal matrix. So if A is orthogonal matrix, Okay, these are the properties actually. Okay, another important property which we'll discuss, that is basically, let me write it down here. So uh, like A is a matrix, and suppose X is a vector, and transpose of that, and then product of these two, where A is m by n matrix, and X is n into 1 matrix. Okay, just remember these things. So this is nothing but actually the norm or square of that. So it will be ax square. But in case, like, if you just remember the transpose rule, A and X transpose mean basically X transpose into A transpose into A into X. And we know from the transpose rule, so let me show that one more time from my previous notebook. We know that um, one second. Okay, and we know that because from this property we have already seen that A transpose is equal to identity matrix. So that's mean it will be xt I x. Hopefully up to this it's clear, right? And the transpose and identity matrix will be same, like t, and this will be x, so which is nothing but um, the norm of x square. Okay, clear up to this? So what exactly we proved here? We proved that for orthogonal matrix, this is equal, let me actually use a different color, is equal to this. So this and this are equal. What does it mean? It's mean we are saying that orthogonal matrix preserve the lengths. So we are saying that orthogonal matrix preserve lengths. Okay, think this is red, this and this is same. Okay, so that's all in today's video. I know it's a little bit of complex one. Hopefully, just review all the sessions a couple of times and you will be able to understand very properly. But these are the very important properties when we'll go to the next videos and next lectures. Thank you. Have a nice day.